Assalamu alaikum, dear students. Our today's topic is for class 12th, subject physics, and the topic is derivation of mirror formula in case of concave mirrors. In the previous lecture, we have discussed about the mirror formula, and we know that mirror formula is a relationship between the three distances, that is object distance, image distance, and the focal length, and that's given by 1 divided by u plus 1 divided by u plus 1 divided by v is equal to 1 divided by f. Today, so we will derive mathematically the mirror formula in case of concave mirrors. So here we consider a concave mirror having pole of mirror P, center of curvature C, an object AB is placed perpendicular on the principal axis. So here we will take two rays of light which are coming from this point. A ray of light that goes parallel to the principal axis. It goes parallel to the principal axis and falls on the concave mirror at this point. So after reflection, this ray of light, it goes through the principal of focus. So it goes through the principal focus. Another ray of light that goes through the center of curvature and falls on the concave mirror at point S, but normal to the concave mirror. So after reflection, this ray of light, it is reflected back along the same path because it's normal to the mirror here. These two reflected rays of light, so it's the first reflected ray of light and second reflected ray of light, they are intersected at this point. So they intersects at this point. Now this point, it will be the image of this point A here. Now the image of this point, it will be on the principal axis. So here it's perpendicular, so we draw a perpendicular here. Now this A dash B dash, so this will be the image of the object AB. So this will be the image of the object AB. Now here we have some distances here. So number one, that is the focal length. So this focal length, it is the distance between the pole of mirror to the principal focus. So and it is denoted by small f. We have another distance here, that is object distance. Now this object distance is the distance between the pole of mirror to the object. So and it's denoted by u. So similarly, we have another distance here, that is the image distance. Now this image distance, it's the distance between the pole of mirror to the image, so and is represented by v. Now out of these three distances, so one distance, or we can say one length, that remains constant, that's the focal length. So focal length that remains constant. Now we can change the object distance. When we change the object distance, this image distance also changes, but this focal length, it will remain constant. Now we will follow here the principles of geometry and the principles of mirror here. So we have here some similar triangles. So we have A, B, C and A dash B dash C. So because this angle is equal to this angle, so here we have a perpendicular 90 degree. So here it's also the perpendicular. Okay. So these two angles are also equal. So other third angle जो है, that will also be equal to, that will also be equal. Now we have another pair of triangles here. So we draw a perpendicular here, L of P dash. Now this L P dash, it's the perpendicular because here A dash B dash. So this ray of light, it's parallel to the principal axis. So we can draw a perpendicular here, L of P dash. Now this L P dash, this will be equal to AB. This will be equal to AB because this ray of light, it goes parallel to the principal axis and falls on the concave mirror here. So we'll take this pair, first pair. We'll take this first pair of similar triangles. So we have a pair of similar triangles. We have a pair of similar triangles. Similar triangles. Pair of similar triangles. A, B, C. A, B, C and A dash B dash C. A dash B dash C. A dash B dash C. So the ratio of their sides, they are also similar. So we can write here AB divided by A dash B dash, AB divided by A dash B dash. So this divided by this side, that is equal to, we'll take this side BC, so it will be B dash C. Yeah, so B C divided by B dash C. So this is equation of first equation. Now we have another pair of triangles here. L P dash F, so second pair of triangle. So here we have A dash B dash F, so this is second pair of triangles. Another pair of triangles, we have another pair of triangles. The ratio of, they are also similar pair of triangles, the ratio of their sides, they are also similar. We can write here, we have another pair of triangles, have another pair of triangles, that is LP dash F, LP dash F, and A dash B dash, A dash B dash F, A dash B dash F. So the ratio of their sides, they are also similar. So we can write here LP dash. So we'll take this side, LP dash divided by A dash B dash. So LP dash divided by A dash B dash, that is equal to P dash F. So we'll take this side. So P dash F divided by B dash F. So we can write it as P dash F divided by B dash F. B dash F. So here this LP dash, that is equal to AB, because this ray of light, this AL, it goes parallel to the principal axis. So this distance, this LP dash, that will be similar, that will be equal to AB. So we can write here, but LP dash, that is equal to AB, that's equal to AB. Then we can write here, therefore we can write this, instead of this LP dash, so we'll write here AB divided by A dash B dash, that is equal to P dash F divided by B dash F. So this will be equation second. So if we compare equation first and equation second, so here we have AB divided by A dash B dash. Here we have also AB divided by A dash B dash. So this and this will cancel to each other. So we'll write here comparing equation of first and equation second. We have so we can write here, so AB divided by A dash B dash, AB divided by B dash, A dash B dash. So this will cancel to each other. So here it is BC, BC divided by B dash C, that is equal to P dash F, P dash F divided by B dash F, B dash F divided by B dash F. No, this will be equation third. So equation third. Now we should know what is this BC, what is B dash C, what's P dash F, and what's B dash F here. So here, as the aperture of the mirror is small, if the aperture of this mirror is small, that means this P dash, it will lie very close to this point P. So I will repeat here, as the aperture of the, or we can say as the diameter of the mirror, or we can say aperture of the mirror, that is very small. If it's very small, then this P dash, it will lie very close to this. So then we can take this P dash F, that's also equal to PF. That's equal to PF. So I will repeat here, as the aperture of this mirror, it's very small, then this perpendicular LP dash, so this P dash, it will lie very close to point P, pole of mirror. Then we take the distance here PF instead of P dash F. So right here, as the aperture of the mirror is small, as the aperture of the mirror is small, as the aperture of the mirror is small, then P dash lies very close to P. P dash will lie very close to P. So therefore, so we can write here, therefore, this P dash F, that is equal to PF. So we'll apply this here. So this P dash F, that's equal to PF. So from equation third, from equation third, so we'll write here BC divided by B dash C is equal to P dash F. Now instead of P dash F, we will write here PF. So it is PF divided by B dash F. Now this is equation fourth. Equation fourth. Equation fourth. Now, from the figure, we will see what's BC. So we'll calculate BC, B dash C. Here we have BC. So this BC and B dash C. Similarly, we have PF and B dash F. So from the figure, we will see what are these terms. So BC now, or BC. So if we calculate the distance of BC, we know that all the distance are measured from the pole of a mirror. So we have to start from the pole of mirror. So we'll write here BC, this BC that will be equal to PB, so minus PC. So it will be, yes, so it will be PB minus times PC, yes, PB minus times PC, PB minus PC. So now we will calculate B dash C. So B dash, this distance we have to calculate, but we have to calculate from we have to measure from the pole of mirror. So we'll write here PC minus times PB dash. So B dash C, that is equal to it will be PC minus times PB dash. Now PF. Now here PF. So it's a distance from the pole to the principal focus. That's the focal length. So PF यहाँ पर जरूरत नहीं है निकालने की. So then we have a B dash F. B dash F means this distance, B dash F. So it is this distance. So that will be equal to PB dash minus PF. B dash F. B dash F, that is equal to PB dash minus times PF. So we'll substitute the values, these values BC, B dash C, B dash F in equation fourth. Put these values in equation fourth. So we'll write here BC is PB minus PC divided by B dash C. So it is PC minus PB dash, that is equal to PF. So that is PF. It is PF. B dash F. So it will be PB dash minus PF. Now here we'll see what is PB PB from the pole to the object, that is known as the object distance. So it will be object distance. Now here PB, that is the object distance, that's denoted by U, but it's on the left side. So we go. So it's on the left side. The distance from pole to the object. Distance from pole to the object, that's known as the object distance, which is denoted by U, but it's on the left side. So we'll take here the sign convention. So it will be minus U. It will be minus U. Similarly, we have PC. PC, that is equal to PC from the pole of mirror to the center of curvature. It is the radius of curvature. We know that that is the radius of curvature, which is denoted by R. From the pole of mirror to the center of curvature, that is the radius of curvature. That is the radius of curvature. So we will write here PC, that is equal to radius of curvature. So we will write it as R. We will write it as R, radius of curvature. But it's minus R. It is minus R. Similarly, we have PB dash. Now PB dash, that is equal to PB dash. So this PB dash, that's the distance from the pole to the image, that's known as the image distance. So it will be minus times V. Similarly, we have here PF. PF is equal to from the pole to the principal focus, that is the focal length. So it will be minus times F. It will be minus times F. So we'll substitute these values, put these values in equation. So this will be equation fifth. Put these values in equation fifth. So here PB. So instead of PB, we will write minus times U minus times C, PC. So that will be equal to PC. So that's minus times R. So we'll write here minus R divided by PC. So that will be equal to minus R minus times PB dash minus times V minus times V. So PB dash. Okay. So that is equal to PF. So that is minus times F whole divided by PB dash minus V minus times F. But we have already discussed about the radius of curvature. Radius of curvature, that's twice focal length. So we'll write here, but R is equal to twice F. So we'll write here minus U. So this will be equal to plus twice F divided by minus twice F plus V is equal to minus F divided by minus V plus F. So we'll cross multiply here. So minus U into this, so it will be equal to UV minus U into this, so that will be equal to minus UF plus, so this will be minus times minus twice F into V, so that will be equal to minus twice FV plus twice F square is equal to, so this will be equal to minus into minus plus, so twice F square minus times FV. So this and this will cancel to each other. We can write here UV minus times UF minus times twice FV. So plus times FV is equal to 0. So this will be equal to 0. So here it will be UV minus times UF minus times So this will be twice FV. So it will be minus times FV. So it will be minus times FV. Minus times FV is equal to 0. So this will be equal to 0. Or we can write here UV is equal to UF plus. So इन दोनों को इस साइड में लेंगे. So this will be equal to FV. So equation 6th. This will be equation 6th. Now dividing both sides by UVF. UVF. So here we'll write UV divided by UVF is equal to UF divided by UVF plus FV divided by UVF. So UV or UV cancel, UF cancel, FV cancel. So 1 divided by F is equal to 1 divided by V plus 1 divided by U. Or we can write here 1 divided by F is equal to 1 divided by U plus 1 divided by V. So this is the derivation proof of, or we can say proof of mirror formula in case of concave mirrors.